So when we look at the theory really is a universal theory. It's a way to tie together the continental drift theory and the theory of seafloor spreading. It basically ties it all together and understanding all of this. And what it really says is that the Earth's crust is made up of these rigid plates, and they move around. And it was thought for a very long time that these slabs of rock were moved around due to convection cycles. And it kind of makes sense, slightly. It would make sense if, if you think about a machine. And let's say that I have this piece of paper that sits over these two gears. And this gear is rotating in that direction, and that gear is rotating in that direction. What would we expect to see happening to this piece of paper?
It's going to tear.
Yeah, it's going to tear in the middle, right? It's literally getting pulled. So basically, we used to think it was these convection cycles that were moving the plates. And what we really started to figure out within recent time, probably in the last 20 years or so, that it's really due to the slab pull that was discussed with seafloor spreading. It was literally the weight of the plates themselves that is moving one into the other. And that's kind of where we really get the plate movement. But it's important that you guys do understand what we think of these as due to the convection cycles. And what we showed you guys earlier in this unit is that the plates are moving in all different directions. They're moving at all different rates, and they're not uniform. In fact, they're not even uniform along the same plate. You have places on the Pacific plate that are subducting into South America, yet are sliding past places in North America. So we don't even have the same type of boundaries on the same plate. In fact, what makes me happy anyway, Los Angeles is in all technicality not even part of North America. It's actually part of the Pacific plate. And given enough time, what we're going to find out is that Los Angeles is slowly moving north to San Francisco. For those of you guys who know San Francisco, I apologize in advance in a few million years. Hopefully LA gets better in that time, but recent trends, probably not. And then, of course, these last two concepts here, not really, some of you guys probably already know, right? When these things are colliding, you have to understand these things are huge. And they pack a lot of energy when they collide. And the reason behind that is if we think about the fact of force. Force is mass times acceleration. That's what force is. For those of you guys that have taken ICP, that's all a force is. It is the mass of an object multiplied by the acceleration of that object. And that's the force that it applies. Okay, so I want you to think about this very quickly. I want you to think about a semi-truck, and then I want you to think about the wonderful Taurus. Not Taurus, sorry. Prius. Okay, a semi-truck and a Prius. Okay, let's take the semi-truck, put it on cruise at 15 miles an hour, and run into a brick wall. Nothing else better to do for a weekend, might as well do that. Okay? What kind of damage is that semi-truck going to do?
A little bit.
I have a feeling it would knock over. How? It would destroy the plate.
Okay. So how much faster would the Prius have to go in order to do the same amount of damage?
They probably can't.
Okay, so we understand that concept, right? That the mass, the heavier the object is, clearly I don't need to go that fast or increase my speed that fast or it has the same outcome. So when we take the tectonic plates, think about the size of the plates and think about their individual masses. Now these things aren't really accelerating very much. Like I said, on average they might slip 1 or 2 inches when they actually collide. So think about that in terms of acceleration. We're not really accelerating that much, but because of their sheer size, there's a lot of force that's connected into that. And from the force, we can then derive how much energy is input. It's a tremendous amount of energy. And that's really when we get our earthquakes. It's simply when these things collide, they slip, it's that sudden release of energy. A lot of force and a lot of energy is packed into these plate boundaries. Yet, a lot of people live along the plate boundaries. A lot of personal damage. Yes?
How do they know when we're gonna have our earthquakes?
They don't.
Like I thought they did sometimes. Like, they're like, we might have one.